All right, the last example on your solving linear inequality section 2.7 is kind of a hard looking problem, but remember when we dealt with problems like this on your homework for section 2.3, we always wanted to remove our parentheses first. So we're actually going to use our distributive property. Now this left side is just going to come down, and I'm going to distribute the -4 to the x and get -4x. The -4 to the 1 and get -4. So this is what we have after we get rid of our parentheses. Now we want to move our variables to one side and our numbers to the other. So this is exactly like our 2.3. So I want to add 4x to both sides to get the x by itself. So I have -6 plus 4, different signs, subtract, take the sign of the bigger number, bring down my -3, bring down my greater than sign, and then bring down my -4. Now I want to get rid of this -3, and I'm going to add 3 to both sides. So I have -2x is greater than -1. To get the x by itself, I'm dividing both sides by a -2. Now remember, when you divide both sides of the inequality by a negative, your inequality symbol is going to change direction. So once it was pointing to the right, now it's going to be pointing to the left. And I have x is less than, if you have a negative over a negative, that's the same thing as a positive. So I have x is less than 1/2. Now I'm going to do my graph up here. Remember, negative infinities to the left, positive infinities to the right. And I just want to give you an idea of where these numbers are on the number line. So, and just to make it a little more spaced out, this is what I'm going to do. I'm going to put 1, -1. This is going to be -1/2 and positive 1/2. So I have, remember you always want to look to see if you're going to use a parentheses or a bracket, and there's no line underneath it, so it's going to be a parentheses. And it's shading to the left. This is the first one we've had to the left in a while. So we're going to shade to the left with a parentheses at 1/2. So a parentheses, and I'm shading all the way to -infinity. So when I shade to -infinity, this is going to make my interval notation start with -infinity. Remember, your interval notation is going to look exactly like your graph. So the first thing that's on my graph is -infinity. Remember, negative and positive infinities always have parentheses. And it goes all the way to positive 1/2. And positive 1/2 has a parentheses also. Now this was the last problem on your notes, but I added a couple from the homework or questions that students had or stuff and so forth. So I'm going to actually flip my page over, and I'm going to work problems that might be on your homework. It might just be things that people brought up in class, but these are things that I want you to see. So the first one is -x is greater than -6. Now this looks pretty easy. It looks like it's already solved, but remember, if you have a -x, that's the same thing as -1. So I want to divide both sides by -1, and when you divide by a negative, remember your inequality symbol flips. So I'm going to have x is less than a +6. Now your graph would be shaded to the left, so I'm going to do that real quick right here. I have a -infinity to the left, positive infinity to the right. For my 6, we are going to have a parentheses because there's no line underneath it, and I'm shading all the way to -infinity. So my interval notation is going to start with -infinity, and it's going to go all the way to +6. Now number 2 looks very strange. The x is by itself. However, the x is not on the left side. I told you when we solved equations that it was very important that your x be on the left side for your inequality section. And I really have not talked about it because our x has been on the left so far. But if your x is ever on the right, your inequality is not going to be like it should. I mean, this looks like I'm going to be shading to the right, which is false. So you always want to flip it and make your x be on the left side. So whatever the alligator mouth is eating, and it's eating the -2, when you flip this inequality, your alligator mouth still has to be eating the -2. So notice that I'm pointing at the x. When I flipped it, I'm pointing at the x. I'm eating the -2, so when I flipped it, I'm still eating the -2. So this tells me that I am going to be shading to -infinity, and I have a bracket at -2. So a bracket at -2, and I'm shading to -infinity. So my interval notation is going to be -infinity with a parentheses, because remember it always has parentheses, and I'm going all the way to -2 with a bracket. All right, number 3, I'm actually going to, I guess, rewrite number 3 down here. I just don't feel like I have enough space up there. So number 3 has a fraction, and the reason why I included this one is because this one is not as easy to find a common denominator. It's not something that you just know off the top of your head. So anytime that you come across a problem like this where you don't know what the common denominator is, I'm going to give you another option of how you can simplify your problems with not knowing off the top of your head what a common denominator is. A common denominator is a denominator that can go into every single denominator that you already have. So if I use all the numbers that we have as denominators, 7, 4, and 3, and multiply it to every single term, remember our goal of our common denominator is to get rid of the denominator that we have. This will solve that problem. This will get rid of the denominator. So I want to cancel the 7 with the 7, and I'm going to have to multiply everything that's left. So 4 times 3 is 12, and 12 times 5 is 60. Okay, so I canceled the 7, and I multiplied everything that's left. 4 times 3 times 5. So 4 times 3 was 12, and 12 times 5 is 60. So for the 4 is going to cancel, or for that middle term. And I'm left with 7 times 3 times 1. So 7 times 3 is 21, and 21 times 1 is also 21. Bring down my symbol. And then the 3's cancel with this last one, and I'm left with 7 times 4 times x, so 28x. All right, so now we have a pretty normal problem. Let me go ahead and combine our like terms on this side. So I have 81 is less than or equal to 28x. And to get the x by itself, I just divide both sides by 28. So I have x is greater than or equal to 81 over 28. And that can't be reduced. The 2 won't go into either, 3 won't go into either, and so that's in simplest form. Notice that this is pretty similar to this number up here. The x is on the right side, so that means that I'm going to have to flip it. So remember, the big mouse eating the x, so when I flip it, the big mouse still needs to be eating the x. Alright? Now, if you have any problems on, if you have a problem like this on your homework and they ask you to graph it, which I don't know that they'll ask you to graph that, but if they do ask you to graph it, to figure out where that is on the number line, you can do 2 things. You can put it in a calculator and get a decimal, or you can divide by hand and get a decimal. You can ask yourself, how many times will 28 go into 81? And so, whatever you get for your decimal, and I'm going to put it in my calculator, and I know I have a little spot, but 81 divided by 28 is 2.89. That means it's going to be in between the 2 and the 3 on the number line. This is very important if you're looking at a graph to determine which graph is correct. So this is closer to the 3, so I'm going to say 2, 3, 4, 5. And it's pointing to the right, so I'm going to shade to positive infinity, and it has a bracket. So I'm going to say there's a bracket there, and I'm shading all the way to positive infinity. My interval notation would be a bracket at 81 over 28, and it's going to go to positive infinity. Okay? The last problem that we have on this page is another fraction, and I just want to remind you how you get rid of fractions. Alright, so remember you want to get a common denominator, and this common denominator is easy. It's 9. That's the only denominator we have. So I'm going to multiply both sides by 9. And I have 7x is greater than or equal to 54. Divide both sides by 54. And x is greater than or equal to 54 over 7. This is in simplest form. I can't do anything with it. If I had 54 over 7 as a decimal, that's, whoops, I must have hit it like 5 times. 7.7, so that's where it would be on the number line. I'm going to show you an interval notation without doing a graph. This is pointing to the right side, so I'm going to have a bracket, because there's a line underneath it, at 54 over 7, and I'm going all the way to positive infinity. And remember, your positive infinity and negative infinities always have parentheses. If you have any other questions on your homework, let me know.